apply the concept of time invariance, although it's quite simple and straightforward, but it is quite important. The time invariance and the linearity concept together will enable us to consider the system output by using the superposition theory, by using the superposition concept to add things together. Now, I'd like to explain the time invariance concept graphically and mathematically. First, now you can see the system with a gain of 2. Then suppose if we have xt 1 here, okay, then another one input here. So this is the xt. Then because the gain is just 2, so what we are actually expecting, the output is pretty simple and straightforward. 1, 2 is simply multiplied by the magnitude by 2. Okay, then we are going to have, okay, so this is the yt. Okay, now yt. Now we are going to consider another one, which is what we call the delay xt. Okay, delay xt is equal to xt minus tau. So in this case, I like to draw in such a way. One here. Okay. So what we can see here, this is the delay tau, and which is equal to this. So sorry, just only the delay tau. So basically we shift the whole waveform here to by tau. Then because of that, then the output quick is simply equal to okay, so this one is equal to 2, so this output xdt or ydt is equal to yt minus tau. Now, so what we can see is we are trying to say this is yt here, this is yt here. Suppose if this yt is going to shift, this yt is shift delay by tau, so the output will become in such a way, then the output will become such a way, so this one will become yt minus tau. Then what we can see that this one and this one, they are equal. So what we can see that this is a time invariant system. Right, I use this kind of example to show a system which is not time invariance. Now the gain is not 2, just like what I shown you before. Now it is cosine omega t. This is what cosine omega t is about. Now I have drawn the waveform first so that it can be quicker for me and no mistake. Right, now this is the xt. Right, the xt is such a waveform. This is what I'm talking about, the xt. And the cosine omega t is this one, is this one, this one, this one, this one. So the output yt in such a way will become this 1 times the cosine omega t in this pi over 2 region, which is equal to something like that. Now, we don't have any system input here, so we'll have 0 here. We start to have 1 for this positive half cycle. So, the system output, this is the system output. What looks like nothing here. So, we've got nothing here. Now, when we are talking another waveform, the x delay t in this case is equal to xt minus tau, where tau is equal to pi over 2 in this case. So this is our xt waveform. Okay, the cosine waveform is still over here. So when we multiply them together, then we have nothing here this time. Got nothing here this time. But we've got 1 multiplied by the minus thing. So we have something here. Then we've got nothing here. We've got nothing here. Then we've got 1 multiplied by the cosine waveform here. Then we've got 1 multiplied by the negative waveform here. So what you can see, the delayed waveform is actually in such a waveform. What we can consider that this is what we call the y dt. If we are considering this yt and then make it into yt minus tau, the waveform will simply become something like that. Then what you can see, this delayed waveform is clearly not the same as this waveform. So this yt minus tau is not equal to this y dt. So in this case, it's what we call a time variant system, or not a time invariant system.